If you just learn game development with Java and libGDX, then building a starter project is a necessary step on your journey to become a better Java game developer. From my own experience, I have always used a starter project as a template for all of my libGDX games. As you already know that GDX libdop can generate projects that are sufficient in most cases. But there are situations where you may want to develop your own starter templates for better reusability. This video will guide you through the process of creating a starter project with all the details and explanations. So this is what we're gonna build, a very simple app in libGDX that has a home screen showing the game titles in the play button. When you click on the play button, it transitions to this game screen that renders the flying ball like this. And you will see that there's nothing fancy at all, it just has the bare minimum project structures with the basic components from the libGDX framework. By the way, this video also has a written tutorial on my website, so if you refer in the text, check out the link below. The starter project has many characteristics of an ordinary game project that use the components. The first one is starter AssetManager, which is a central class to store and load game assets including graphics, fonts, sound effects, and tile maps. Then we have a collection of screen classes, which are the basic building blocks of the game. Loading screen is responsible for loading the assets while optionally displaying a progress bar. It transitions to the home screen when loading is finished. Home screen displays the game titles and the play button. It transitions to the game screen when the player clicks the button. Game screen is the main gameplay screen, which implements the game logics and mechanics using the render loop. You can optionally transition back to the home screen. Aside from the screen classes, we're gonna need a constant class, which is a central class to store and retrieve the game global settings. Finally, starter project is the main entry class responsible for initializing the core components and bootstrapping the game. So our roadmap for creating a starter project will include these steps. Number 1 is to generate the project skeleton using GDX libdop. Number 2 is to automate TexturePacking with Gradle task. Then we need to create an AssetManager class to load the game assets. After that, we can create boilerplate screen classes, including loading screen, home screen, and game screen. And then we need to add a constant class and implement the entry class. Finally, we add the implementation for the loading screen, home screen, and the game screen. Now that we have the roadmap, let's try to execute them step by step. First of all, let's use GDX libdop to generate the project skeleton. From the terminals, launch GDX libdop using the command line. Once the UI shows up, enter a project name, packages, and main class name, then hit project options. On the add-on screen, select the classic template so we have some boilerplate to work with. For the platforms, select core, desktop, and HTML, then click next. On the third-party screens, we don't use any extension, so just click the next button again. On the settings screen, select the project locations and click the generate button to generate our project. And this will generate a libGDX project with some boilerplate close for you. The first thing I want to do is to change the default window dimension to 1280 by 720. Open the file libgjl3 launchers and change the parameters in the set window mode method to 1280 by 720. Now run the Gradle task libgjl3 run to test your project. Moving on to step 2, we want to create a Gradle task to automate TexturePacking, so let's do that. Go to my website, ransomsoft.com. In the footers, click the code snippet links. This will open up the code snippet page. Click the link Gradle task TexturePacking in the left sidebar to jump to that section. Now let's edit the file build.gradle in the root of your project. Let's copy the dependencies from the snippet page and paste it to the dependency block of the build.gradle file. Then copy the Gradle task from the snippet page and paste it at the end of the build.gradle file. And that's it, you just got an automated TexturePacking task for your project. Now we can test if this task is working correctly. Create a graphics folder and a subfolder images inside it. If you run Gradle TexturePacker right now, it will scan the images folders and pack all the files inside into a single atlas file. Since we have nothing inside images folders, let's generate a simple sprite. cd into the graphics images folders and let's make a simple circle sprite using Magic Key. This command will generate a white circle named report.png inside the images folder. Now let's go back to the project folders and run TexturePacker again. Checking the output, you can see that there is a game.png files have been generated in the assets folder. There it is, the sprites in the images folders have been packed into a texturepacker file. Now if you open the project again and view the file game.atlas, you see the configuration for the sprite has been added correctly. Perfect, so our next step is to create an AssetManager class to load the texturepacker we just created. In the core package, let's add a new file, starter project AssetManager.java. Then edit the file and make it extend AssetManager class. In the constructors, let's call the super method for initializing the variables of the parent class. Now you can load the texturepacker that we have just created in step 2. In step 4, we're gonna create the boilerplate code for multiple screen classes. First of all, let's add a new screens package. Then, inside the package, add a gamescreen.java file. Edit the file and create a new gamescreens class that implements the screen interface. The screen interface requires a few methods implementations. For now, we just leave them empty and come back to them later in step 7. Now add the game screen constructors. Inside the parameters, add a references to the main entry class starter project. Now the main reasons we want to save a reference to the entry class is that it contains only essential libGDX objects such as sprite batch, camera, viewport, asset managers and many others. So saving this reference that allows us to get the objects later in our development. Perfect, we just create the game screens class. Now let's add loading screen as well. Inside the screen package, add a new file loadingscreen.java. The process of creating loading screen is exactly the same as game screen. You just need to add all the screen interface methods and make references to the entry class in the constructor. Again, just delete the boilerplate because we're gonna add our implementation details later. Public loading screen, use starter projects as the input parameters and save the reference in the game variable. Finally, add a home screen class similarly to the game screen and loading screen. You get the idea, so I'm going to fast forward it. Now in step 5, let's add a constant class to save our game global settings. Create a constant.java file in the core package. Edit the file and make a new class with the same name. Inside the class, we're gonna create some common static variables such as the viewport width, height, and the clear color. The constants will be used when we initialize our viewport and camera instances in the entry class. And inside the render loop, we're gonna clear the screen using the color. Here I'm just picking a dark gray color. Depending on your game design, you can pick any color that you want. We have just created a lot of classes from previous steps. Now let's initialize all of them in our entry class. Edit the file startup.project.java. First off, let's remove the code that draws the libGDX logo on the screen. Now let's add the core libGDX components, starting with the camera. Initialize an orthographic camera instance with the world width and world height constants we just created earlier. Now let's add a new feed viewport using the same viewport dimensions and the camera instance. By using the camera with a viewport, your sprite size are independent of the screen physical resolution, so they look the same on different devices. Then you can initialize the asset managers and the stage instance to render our UI components. Here we just initialize the asset managers class that we create in step 3. We need the stage objects added scene to the base components. The stage is commonly used with the screen viewport. Later on, we can add several scenes to the widgets to the stage and render them on our game screen. Finally, we need an input multiplexer to handle multiples of inputs from your game logics and scene 2D components. The input multiplexers can accept several input processors, and stage is one of them. Later on, you can add your own input processors to respond to user inputs along with stage. Now let's add stage to the multiplexer first. Then set the multiplexers as the main input processors of the game. Because we have two different types of viewports, we have to update their dimensions when the screen resizes. Let's override the resize methods and update both the game viewport and the scene 2D viewports with the new screen dimensions. The parameters here are the new width, height, and whether you want to center the cameras as the window changes. The final part of the engine class is to initialize our screen instances. Let's add the game screen, home screen, and the loading screen instance variable first. Then we're gonna add set a method to set the active screen of the game, starting with the game screen. If game screen has not been initialized yet, let's create one. Game screen equals to new game screen. Now by default, the classic template extends the application adapters, which doesn't have the set screen methods. Let's change that to the games class. After that, we can call the set screen method to set the current screen at the game screen. And we can do the same with the loading screen and the home screen, just add the set loading screen and the set home screen methods as well. We can simply copy and replace the game screen keywords because they are exactly the same. I'm just replacing the game screen variable with the home screen. Remember to use the correct constructor as well. Then you can do the same with the loading screen and the process is the same. And this is not limited to just these screens. You can repeat the same process every time you want to add a new screen to your game. Once we have on the screen settings ready, let's go to the render methods and call render on the active screen. So by using screen setters, we can dynamically change the content that we want to draw at any time, whether it's the home screen, the loading screen, or the game screen. And that's it, we just finished part 1, including 6 steps of the tutorial creating a starter template project in libGDX. See you in part 2, where we add on the implementation details for our screen classes in step 7.